Thank you very much for being here to listen to this new presentation. I will try to be as concise as possible. I know it's almost lunchtime. My name is Corrado De Gioia Carabellese. I'm not Mattias Sarati because unfortunately he's sick, but you can reach us, you can reach me at our booth or through LinkedIn. Just a couple of words about Frascold. We are compressor manufacturers. We not only supply compressors, but we also try to share as much as possible our experience to support customers during their entire customer journey from the very beginning to the end. Regarding the transcritical CO2 market, it's very nice to see this increase in the market. We have some numbers here. Every year they follow a sort of exponential curve. So there are a lot of opportunity, a lot of markets in the future, not only related to commercial refrigeration, that is the main market in which the CO2 was implemented in the past, but also in heat pump application. We see not only Europe, in which we are a little bit ahead compared to other countries. We have a very good, interesting numbers also outside Europe, especially with a very huge increase in USA, Canada, but also in Japan, that is a well-established market, and other countries that are coming up. We have said not only commercial refrigeration, because we see a very positive trend also in heat pump application. Unfortunately, last year and also at the beginning of 2024, there is a slightly decrease, but this is mainly due to a lack of incentives and regulation that need to support more in the future this market. We are confident that from the next year there will be much more subsidies and incentives to support this trend. So regarding the application, from the beginning we have seen the CO2 being used in commercial refrigeration, industrial refrigeration, and air conditioning. Commercial refrigeration with very interesting integrated systems that are becoming more and more complex all over the years. But in the last years, we have also seen a great demand for high temperature application, heat pump application, going from domestic hot water, well established also in Japan, but through process heating, district heating, which the capacity, of course, are much higher compared to the other application. And this is a very, to summarize our product range, going from very small compressor, from almost 2 cubic meter per hour at 50 hertz, up to 38 cubic meter per hour at 50 hertz. We have now also, we are going to release, you can see it at our booth, bigger sizes, almost twice the one indicated there. It's 80 cubic meter per hour. In our product development, we are focusing a lot on CO2 the reliability of this CO2 system, because of course having very high pressure, you need to keep the system very reliable. And the other point is they are very complex systems, especially in commercial refrigeration compared to standard refrigerant and hydrocarbons. So we have in mind the reliability first and efficiency second, but again at the same level of importance. And we are developing this series also with the heat pump market in mind, because there is a huge potential. And we will see in the future much more interesting related to this application. This is just an overview to summarize the application envelope of our transcritical compressors. These are 2 different motor sides, from the smaller one to the full-size motor that allow us to reach very high, harsh condition, very burdensome condition for the most heavy applications. What was important, we just say the reliability, because they are very stressed application, which is not only the efficiency the main topic, but the reliability need to be always guaranteed in all operating condition. We have developed this series with this purpose, so with a different internal design without changing anything outside, so it's 100% compatible, but increasing over-dimensioning the internal components to withstand as much as possible the design condition of CO2 requiring CO2 application. And because we all know, when you design a certain plant for a certain application, the design condition usually after a couple of years is not the same. Maybe it's require more burdensome condition. And with this in mind, we have over-dimensioned the components to withstand also this condition. This is just to give you a brief overview of what we have changed inside the compressor. Main changes are related to pistons, connecting rods. We have changed the materials, piston rings, a new material, new shapes, and so on. Another important, this is for reliability. So pistons, connecting rod, piston rings is mainly for reliability of the compressor. On the other hand, the same level of importance, we are changing also the motor to increase as much as possible the efficiency, evaluating also new technology, not only the standard asynchronous motor, but also motors with a permanent magnet inside. This is for that reason we have also developed in parallel to the standard heavy-duty series, that is for the HD stands for, with the LSPM solution already available for these sides. And this the CO2 is very interesting because using this kind of technology related to the motor allow us to gain a very interesting increase in performances. So compared to other refrigerants, this is of course one of the most interesting for the LSPM technology. We are not only we are doing also a step forward within the year to test also another technology that is the IPM, usually more used for bigger sizes, but allow us to reduce the size of the motor, so potentially a decrease of cost with a further increase of efficiency compared to the LSPM. Sorry. This is just to see inside in our application envelope what could be the potential benefit of using a permanent magnet motor. So we see huge increases. There are no refrigerant like CO2 that allow us to reach that level of gain in efficiency. Changing, they are based on the operating condition, but it's very interesting for the heat pump market, for example, because if you want to stress a lot the conditions, so reaching very high pressures, discharge side, gas cooler side, we see using this technology, we are able to further increase the results with a big benefit when you need to take into account the cost of your system. We have also done some simulation because in our selection tool that is completely free, available, we are also very open to optimize it based on your specific request. We have done some seasonal simulations. So again, the point with CO2 is not only the evaluation of the design condition that maybe you reach it for very few hours over the year, but it's very interesting to do a seasonal simulation in which you can take into account the entire year with all the possible temperature over the year. And using the LSPM solution with the main compressor, so the one inverter driven, we can see the results that are very interesting. We can achieve a 6% decrease in the energy consumption without going through all the numbers that I don't really like showing a lot of numbers, but it's just to take the final results. It's a reduced consumption of more or less 6%. That is quite interesting. Maybe this is for commercial refrigeration, but if you have an heat pump in which you constantly work at very high burdensome condition, this gain could be even higher. Again, we've seen the energy consumption gain. This is the gain in COP. That is much more interest for final customers. There are huge potential. Again, we have known the CO2 for commercial refrigeration, but we see very high potential, not only CO2, but also all other natural refrigerants, especially hydrocarbons, for a huge increase in the future. And we are really ready with our products to reach the highest level of efficiency without forgetting that one of the main points with CO2 is the reliability. And we want to stress this because we have designed this series with this in mind, with this point in mind. Reliability first, efficiency second, at the same level of importance. So thank you very much. I'm not Mattia Sarati, I'm Corrado Carabellesi. If you want to have additional information, you can reach me now or at our booth. Thank you very much.